So the main reason I wanted to give this talk today is to highlight what I believe to be an underutilized resource within digital forensics and incident response and cybersecurity as a whole, and that is cloud billing data. The amount of information your cloud bill holds is pretty remarkable, and the capabilities of a lot of the built-in analysis tools and alerting capabilities within these cloud platforms is pretty incredible. So I know the word cloud is very broad. So when I say cloud, I'm mostly referring to cloud compute and platforms such as Amazon Web Services, Microsoft Azure, and Google Cloud Platform. However, the information that I will cover can likely be applied to other platforms as well. Really anything with billing data and cost analysis tools should work. So I'll skip the required disclaimer slide. I'm sure we're all familiar with that by now. And just a real quick, who am I? My name is Andre Macaron. I'm a director at Strauss Freeburg Digital Forensics and Incident Response. And so we are a DFIR consulting firm that is part of Aon Cyber Solutions. In my role, I lead all sorts of complex cyber investigations ranging from cyber extortion, wire fraud, intellectual property theft, and nation-state incidents, to name a few. So in many of these investigations, we encounter some element of cloud compromise. And unfortunately, the ideal logging is not always enabled. And that's really where analysis of cloud billing data has played a vital role in answering some key questions during an incident. And later on in this talk, I'll go through a couple case scenarios of how I've used cost analysis to help answer some of those key questions. So some of you might be thinking, but Andre, I am in cybersecurity, not finance. Why should I care about my organization's cloud bill? Let me tell you. So cost analysis can help us identify existing threats within our organization. So threat actors love to spin up resources. They love to transfer large amounts of data given the opportunity. And these actions leave a financial footprint. And so by analyzing our billing data and looking for cost anomaly or service cost and usage anomalies, we can potentially identify a malicious actor in our environment. In addition, we can set up alerts for when there's anomalous charges occur, similar to how you get a credit card notification when you make a large purchase. Was this me or not? We can set up similar types of alerts in our environment to serve as a potential early warning. But if we already have a breach, and what can cost analysis help us with? Well, we can enhance our understanding of an incident by looking at our cloud bill. We can answer questions such as how much data was transferred during the compromise window, or when did that anomalous service start, right? And we can enhance our understanding of the timeline. And third, it's a cost-effective addition to your security suite. The billing data already exists, and the tools are free for use, and you can set up alerts with no additional cost. So why not use it? So this is what you can expect in the next 35 minutes or so. We'll start with an intro to how billing in the cloud actually works. We'll then move into the tools that are available for cost analysis and how to use those tools to identify existing threats in our environment. The second half, we will go through a couple of case scenarios of how I've used cloud billing to help answer key forensic questions during an incident. as well as how we can set up alerts in our environment, and then some key takeaways and action items. So before we get started and can effectively analyze our bill, we need to understand, at least at a high level, how billing in the cloud works. And the three major cloud computing platforms, AWS, Microsoft Azure, and Google Cloud Platform, have similar billing models that can be broken down into three different pillars. The first is flexibility and scalability. So the cost is flexible because you only pay for what you use. There's no licensing requirements, there's no long-term commitments, and there's no hardware investments. So you can spin up resources as you need them and spin them down when you don't. The price is scalable in the sense that the more you use, the less per unit you pay. So to give an example, in AWS, your first 50 terabytes of S3 data storage is going to be at a certain price per gigabyte. Your next 50 terabytes will be at a slightly discounted rate per gigabyte. So it's tiered. The second pillar is commitment-based discounts. So if you do know you're going to use a resource for an extended period of time, you can commit to that resource typically for 1 or 3 year commitment periods, and you will get that resource at a discounted rate. And then the third is transparency and predictability. So if you go to any of these cloud providers' websites, you'll find a very detailed breakdown of how each service is billed and at what rate. In addition, these platforms offer tooling that can help us track our historical cost and our forecasted cost, which we'll talk about very soon. So that's at a high level, the general billing philosophy and model, but what actually drives the cost? So the first is compute services. These are your AWS EC2 instances, your Microsoft Azure virtual machines, and these services are billed based off of computing capacity and operation time. So the more CPU and memory that's allocated, the higher the cost. And these services are typically billed per hour or per minute or per second, generally shorter time frames than some other services. We then have storage services. And storage services, there's object level storage services such as Amazon S3. There's also block storage services such as AWS EBS and Azure Managed Disk. And these services are generally billed based off of storage capacity, the amount of time that the data was stored, and the rate of retrieval. So your SSD volumes are going to be more expensive than your HDD volumes. And typically these services are billed on a per gigabyte per month basis. Next, we have network and data transfer services. So these are charges that are generated when we transfer data out of the cloud between services or between regions. What's interesting about data transfer in the cloud is that you are typically only charged for downloading data from the cloud and not for uploading data to the cloud. In addition, if you are keeping data in the cloud and you're moving it between services or regions, it's typically going to be at a lesser price per gigabyte than if you download data from the cloud to the internet, some other source outside of the cloud. And then we have other managed services that might be billed at a specified rate depending on the service. These are your machine learning services, your security tools such as AWS GuardDuty, and database services. So let's move into the tools that are available for cost analysis. So the first tool is AWS Cost Explorer. So Cost Explorer is a built-in tool within AWS that allows us to visualize our billing trends. So you can see the bar graph is color-coded based off of service, and it shows the last 6 months. And we have various customizable options, such as a date range filter, so we can specify a custom time frame. By default, AWS offers 13 months of historical billing data, as well as 12 months of projected forecasted cost based off of current service usage and trends. We then have granularity, which we can select monthly or daily and essentially get a more narrow view of or a more specific time frame. By default, these are the only two options, but you can enable hourly granularity, but it does cost. You do have to pay for that. Next, we have group by. So this is what the graph is grouped by. In this case, it's grouped by service. So each color represents a service. We can group on all sorts of things such as region, API operation, availability zone, and others as well. We then have filters. So filters, similarly, we can filter on specific services, specific regions, API operations. Filters are really useful for narrowing down and getting really specific to drill down into a specific cost, as we'll see. So Microsoft Azure has a similar tool under cost management and billing. And again, it's very similar. You have a graphical representation of your spending, and it can do historical and forecast as well. It also has 13 months of historical data as well as 12 months of projected cost. We also have very similar customization options, including time frame filter, granularity, group by, and filter. Google Cloud has, again, another similar tool under cost management called Reports. And this, again, lets us visually see what our spending is. We have similar filters as AWS and Azure. One of the things that is nice about GCP is that the billing data actually goes back to January of 2017. So you can get you can really drill down into your historical cost. So how can we use these tools to actually identify threats in our environment? So I will be using AWS Cost Explorer. It'll be easier to follow along if I use a single tool. This way we're not changing naming conventions and things like that. But you saw in the list section that the tools are very similar. They all have similar features and filtering capabilities. So what I do with Cost Explorer, you should be able to do with the other platforms as well. So in order to identify an existing threat, the first thing we need to do is establish a baseline. So, using the historical data that's available to us in these cost analysis tools, we can see what is normal in our environment, right? What services are in use? What is the general range of costs that we're spending on these services? And we can use that baseline to then look for anomalies. So one anomaly might be a spike in service cost and usage, right? If you're transferring large amounts of data, that's going to generate a spike. If you're increasing the computing capacity, that's going to generate a spike. We can also look for charges for services that our organization does not typically use, right? So looking at the current month's service usage versus what we know our organization typically uses and finding the outliers. We can look for charges originating from different regions that our organization does not typically operate in, or spikes in regions that we operate in pretty minimally. And then finally, activity from untagged resources. So if your organization has a tagging policy, so when you spin up an EC2 instance or virtual machine, a lot of times you can assign a key value pair, for example, for a project. So all of my EC2 instances for a certain project will have a tag. So threat actors do not tag resources. They do not take the time to do that. So if you have a strict tagging policy, then any untagged resource should stick out. So let's take a look at an example of a spike in service cost and usage. So here we are grouped by service, and we are looking at the last 6 months of service usage. And we can see in January of 2024, there was a large increase in EC2 instance spending. So if we drill down on that expense and change the date range to January and change the granularity to daily, and then group or filter on service equals EC2 instance, we can see that there was a spike that started January 15th in EC2 cost. If we take that one step further and we group by instance type, we can see that there's a new instance type charge for an instance type of G3 4x large. Now, if you're not familiar with AWS instance types and naming conventions, typically the prefix of a G indicates a graphics optimized instance. And what are graphic optimized instances great for? Crypto mining, right? So using cost analysis, we could then, so we identified this using cost analysis. So now our next step would be to dig deeper into this by looking at other evidence sources, such as your CloudTrail logs, to see which user created this instance on January 15th, and then ask that user, did you do this or not? Or look at the source IP and see if it's a host and provider, or perform further forensics to figure out what exactly this instance is doing. So similarly, we can look at anomalous region usage. So by grouping by region instead of service, we can then look at our spending per month per region and see if there's any spikes. In this example, we have 2 months worth of expenses, and we can see that in March 2024, the EU Ireland region had a large spike compared to last year. Now, this spike could be because your organization recently expanded into the EU, or maybe you are working on a large project based out of the EU, right? Or maybe it's a threat actor that spun up resources in the EU region. The point is, just because there's a spike doesn't mean it's malicious, but these are the anomalies that you want to look out for and you want to investigate further. And similarly, we can also look at the services for the current month and compare those to the historical baseline. So some of the services that we see threat actors commonly use include services that allow for malicious code execution, such as AWS Lambda and Azure Functions. We've seen threat actors use these to deploy crypto miners. DNS-related services such as Route 53 and Azure DNS These are services that threat actors can use to hijack domains or register their own domains and use those for command and control. There's also resources or services that allow for bulk deployment. And we commonly see these types of services such as CloudFormation and Deployment Manager being used to deploy resources at scale. I've seen a threat actor deploy hundreds of thousands of dollars worth of EC2 instances for crypto mining purposes using CloudFormation. Additionally, we can look for communication services, SMS and email communication services, such as Pinpoint or Azure communication services. We commonly see threat actors use these services to send spam out to customers or email distros. And additionally, we can look for asset management services like Systems Manager and Resource Graph. These are services that provide great insight into your environment in terms of which operating systems you're running, which applications and services you're running, and it can be a valuable resource for a threat actor that's trying to understand your environment. So that's how we identify existing threats. But what if we already have an existing threat? How can we use cost analysis to learn more about an incident? So let's look at the common problems in cloud forensics. So a lot of the ideal logging is not always enabled. So S3 object access logging is an example of this, right? If we wanted to see which files were downloaded from an S3 bucket, we would need object access logging. And unfortunately, that's only enabled if you enable it. A lot of times we don't have that. If we want to see how much data was transferred off of an EC2 instance, we need VPC flow logs. And again, it's not enabled by default. So additionally, even if these are enabled, if the threat actor has the proper permissions, they can just delete them. We've seen that many times, unfortunately. And then sometimes we have the logging, but the sheer amount of data that we have is overwhelming, and it's going to take days or weeks to sift through the data. We don't really know where to start. And cost analysis can help us pinpoint specific buckets to look at or specific instances or regions to look at and really narrow it down. In addition, we can reconstruct a timeline of the incident. So we can see when that anomalous service usage started and when it ended. We also can help understand the scope of the incident by looking at the compromise window and seeing what charges for which services were incurred. And that can provide some clues as to which services might also be compromised. And finally, we can quantify threat actor actions, right? So how much data was transferred during a specific time period, or how many messages were sent, as we'll see in one of the case scenarios. So let's take a look at this case scenario where a client executive team receives an extortion email. The threat actor claims 500 gigabytes of exfil, and the client's IT team identified 3 S3 buckets that were publicly facing. But unfortunately, they didn't have object level logging enabled. So, using AWS Cost Explorer, we can filter on a time frame, and in this case, we're filtered on a 30-day window with the daily granularity, and we're filtering on usage type group S3 data transfer internet out. And this will tell us how much data was transferred from S3 out to the internet. And you can see, based off of the bar graph, that there was 4 days where data was transferred from S3 via the internet. So we can take it a step further by grouping by tag. So in this case, the client had a tag called name. So we group by tag name, and we can see that there's 3 S3 buckets, prod 1, prod 2, and prod 3. And we can see that prod 1 had about 475 gigabytes of data transfer. We can see prod 2 had 10.7 gigabytes of data transfer, and we can see that there was no data transfer from prod 3. Now you can imagine that this will be very useful information, especially if prod 3 is the only bucket that contains sensitive info, right? That's going to be very valuable to the client. Additionally, not all data transfer is necessarily data exfiltration, right? There can be network overhead and metadata that's not necessarily, sensitive files or anything like that. So what we can do is we can group by API operation. And we can see that on March 30th, that 1.5 gigabytes of data transfer was associated with this API call called list bucket. Now, list bucket provides metadata around buckets, but it doesn't actually download anything from the buckets, right? On that same day, we can see that 0.01 gigabytes of get object data transfer occurred. Now that's the API call that we would expect to see if data was actually downloaded from a bucket, right? So this looks like the threat actor is likely doing reconnaissance on the buckets and then maybe downloading a couple files to see if they have the permission to do so, right? And then over the next couple of days, we see 10 gigabytes of data transfer via get object. We see 320 gigabytes of get object, and then we see 167 gigabytes of get object data transfer, right? So it looks like they came back and took the data. So let's recap. Using cost analysis, we were able to validate that the threat actor has around 500 gigabytes of data. We were able to determine when the data was transferred and how much. And then we were also able to determine the source S3 buckets in which the data was actually downloaded from. So let's take a look at one other case. This will be a Microsoft Azure case. So just going to show some of the capabilities there. So in this case, the threat actor compromised an IT admin account. They were able to create a communication application, and then we can see that they deleted it several hours after they created it. Unfortunately, logging for this application is not enabled by default, and of course, the threat actor didn't enable it for us. So what did the threat actor do with this app, right? Cost analysis can help with that. So we can see that this communication app had $1.67 of data charge. And we can see that $1.66 is associated with leasing a phone number. And less than 1 penny of that charge is related to inbound SMS messaging. If we look at Microsoft Azure's documentation on sending and receiving messages, we can see that they charge 0.075 cents, or 3/4 of a penny, for sending and receiving messages. So using cost analysis, we can infer that the threat actor received one message but didn't send any messages out, since there's no outbound charge. So using cost analysis, we were able to rule out the possibility that the threat actor used this communication service for a mass spam campaign, right? Another great success. So let's take a look at how we can set up alerts in our environment. So in AWS, we have cost and usage alerts. So the first service is called AWS Budgets. AWS Budgets allows us to set a threshold and then alert us when we are at either that specified threshold or you know, at a certain percentage. So for example, we can say, alert me when I hit $15,000 of EC2 instance usage. AWS also has a service called cost anomaly. And this is where AWS uses machine learning to figure out what is normal spending in your environment, and then you set a threshold of when that spending deviates from the norm. So in this example, it would be, alert me when machine learning detects that I am 10% above my expected EC2 usage fee, or usage quota. So really the big difference here is budgets, you specify the threshold, and AWS cost anomaly, the machine learning sets the threshold. So let's take a look at how we can set up a AWS budget alert. In this case, we will set up a budget alert for AWS S3 data transfer. So it's a 4-step process, and first we start with a budget type. So we can choose a cost budget or a usage budget. So cost budget is going to be a $1 threshold. A usage budget is going to be a gigabyte threshold. So we'll choose usage budget. We'll then select usage type group S3 data transfer internet out. The same one we used in Cost Explorer, we can use here. We'll then set a budget amount where we are going to set a budget amount of 30 gigabytes from S3. 30 gigabytes was determined based off of last month's usage. So you would choose a number that is viable for your organization based off of your baseline and what's normal. So in this case, we did 30 gigabytes. And then we can set both actual cost as well as forecasted cost, or forecasted budgeted amount. So in this example, we have an alert set up for when we reach 80% of our budgeted amount. So when 80% of 30 gigabytes of S3 data transfer occurs, alert us. We can also set a forecasted alert that says, in this example, alert us when I am forecasted to go 10% over my expected data transfer. So you can do both, and the forecasted is nice because it will alert you proactively as opposed to after it already happened. And then we just choose the email recipients that we want the notifications to go for. Pretty straightforward. Cost anomaly detection, very similar. This is even easier. Essentially, you just create a monitor. We want to monitor all AWS services. And then we set the sensitivity level, right? So alert me when I am 10% over my expected spend across services. Or alert me when I'm $1,000 above expected spend across services. Microsoft Azure and Google Cloud have very similar machine learning alerting capabilities, as well as a budget equivalent. I won't get into how to set those up, but just know that they exist. If your organization is not an AWS organization, Azure and Google Cloud have similar capabilities. What's actually really cool about Azure and GCP is you can actually set actions to occur after or when an alert was triggered. So I can set an action for if I'm $1,000 over my EC2 instance usage, shut that instance down. So you can set actions like that, which is pretty cool. So some considerations and limitations. So a lot of these organizations offer free tier usage. So free tier might not show up as a cost, so you won't see a spike. However, many of the tools that we just covered have check boxes that say, show me the free tier usage, because these platforms want to show you how much data you're getting for free, or how much usage you're getting for free, to incentivize you to use the product. Reserved instances, essentially what these are, you can purchase a specified amount of resources up front, and so that will look like a spike in your cost analysis, but really you just purchased a specified amount up front. So just things to be aware of. And then credits and discounts may also skew your cost. Again, these tools usually show you where the credits and discounts were applied. So you should still see those, but just know that they can affect the overall graph. Some services are billed annually or monthly, so you'll see a spike very often on the first of the month or the first of the year. That's often just because some services are billed monthly or yearly. DNS services are an example of that. And then additionally, some costs may take up to 24 hours to actually show in the cost analysis tools. So this isn't real time. It's not going to replace an EDR. It's not going to replace your AWS Guard Duty, but it is still a useful tool, as you've seen throughout the presentation. So action items. So next week, I would recommend learn which tools are in your environment, right? I showed a couple examples, but there are additional tools. There's even some third-party tools as well. If your organization uses something like IBM Cloud or something other than these three platforms, learn what tools are available and what the capabilities are. Then establish a baseline of what's normal in my environment, and then look for anomalous activity. See if anything stands out from that baseline. Within 3 months, I would recommend look to set up alerts. So there's usage alerts and cost alerts. Set up the machine learning alerts. Again, these tools are free. They can serve as early indicators to a breach, so why not use them, right? And then within 6 months, I would recommend setting up a tagging policy within your organization, because it really does help with drilling down into cost. So as you saw with the S3 bucket, the client had a tag called name with the S3 bucket names. We could then group by that tag or a project tag or really any other tag and see what the spending is there. And it's easier to spot anomalies, right? So thank you very much. Follow us on X at StraussDFIR, or check out some of our cool blog posts at aon.com/capabilities/cyber-resilience. So really appreciate everyone being here. And yeah, happy to take any questions if anybody has anything. There's mics over in the middle of the floor.
Any experience or recommendations on any third-party tools around this capability?
The one thing that I think is really cool with Microsoft Azure's cost analysis is that you can actually feed in other platforms. So like AWS, you just have Cost Explorer, you just have AWS data. But Azure actually lets you feed in other cloud platforms. In terms of other third-party tools, I haven't personally really used any. Most of the time, I'm doing it from a client's environment, and they don't have these tools, unfortunately, in place. So, but there's definitely some out there. I just, don't have the experience to recommend one or another. But
See,
All right. Thank you, everybody. Appreciate it.